Nuquist plot. Yesterday we have seen a problem, okay, basic problem. Yesterday we have seen a problem based on this, which is that there is no poles at 0. Okay, so today we are going to see one more problems. Let me tell you that first what kind of Nuquist plot are there. Okay, first what you want to know basically from the Nuquist plot means, see, Nuquist plot is similar to polar plot only, but it is an extension of polar plot. For the polar plot, frequency ranges from 0 to infinite. That's it. Only the positive frequencies for polar plot. Only the positive frequencies. Whereas in Nyquist plot, negative frequency will also come. That is, the frequency ranges from minus infinite to infinite. That is the difference between polar plot as well as Nyquist plot. Okay, Nyquist plot what it is? The negative frequency will come to exist, which is the omega value ranges from minus infinite to plus infinite. Whereas in polar plot, the ranges of frequencies from 0 to infinite, that is positive frequencies allowed. That is the difference between Nyquist as well as polar plots. Okay, and what is the purpose of going for Nyquist plot? Is to determine the what? Stability of the system. Okay, so far here we have discussed what? So far we have calculated the stability of the open loop system. Okay, by using the Nyquist plot we can calculate the closed loop system. For a closed loop system, how the stability of the system will be, that we can be predicted by using the Nyquist plot by taking the whose response, the frequency as the response. Okay, and next I told you this is our function, that is this is our system g of s h of s. How should it be in the form of the transfer function, that is s minus some zeros, okay, up to n number of zeros. Likewise s minus poles, that is up to n number of poles. I have taken number of poles as n and number of poles as m. Okay, so far we have discussed many transfer function. There what have you noticed? Number of poles will be greater than zeros. Have you noticed that? Always we have the denominator only s into s plus 1 into s plus 2. Numerator there may be zeros or there may not be. Sometimes there will be one of the zeros will be there. Okay. Always, most of the cases we can say that number of poles will be greater than number of zeros. This is a condition in the Nyquist plot. Okay. Number of zeros should be greater than the number of zeros. Okay. And next we are going to select the Nyquist plot. Okay. Three types of plots are there. One, when the poles are on the imaginary axis, only on the imaginary axis. Okay, no poles on the imaginary axis, which is here. When there is no poles over this imaginary axis, this is the real axis. Okay, so over this here it is what? J omega. This is termed as what? Sigma. This is a real angle. When there is no poles over the imaginary axis, which is here, there is no poles means only our poles exist over here. Okay, if it exists over the left half of the S plane, our Nyquist plot contour will be like this. Just three sets. C1 from where? For C1 mapping is from 0 to infinite, and again C2 from over the infinite number of R through the real axis, and C3. This is yesterday we have seen a problem, and minus infinite to 0 C3. When there is no poles in the imaginary axis. Okay. The next condition is there is no origin as well as no imaginary axis, which means transfer function should be like this. See, g of s, for example, I have here. Okay, this is an example for yesterday's we solved a problem, right? For example, for that is k divided by s plus 5, s plus 2 into s plus 5. Okay, so here is an example that is provided with the origin. There is no origin. Okay, so just s plus 2. S plus 5 or here there is k. Okay, so if the transfer function like this, if there is no origin as well as no origin means what? There is no s into term. S is equal to 0. There is no this term. There will not be the poles. S is equal to 0. If it does not there means as well as the poles are not in the imaginary, which means there will not be any complex poles. Okay. So when it will be imaginary, if it is like this 4s square plus 4s plus 2, if you solve it, what it will become? 2 plus j some constant. Okay. So likewise 2 some j into some constant will become. At that time who comes there? That is imaginary axis. If these two conditions, there is no s is equal to 0 poles and there is no imaginary pole, then your Nyquist plot will be like this. Okay. So where is it here? I have marked here. This is an imaginary axis pole. Nyquist plot go from here. It will overtake the imaginary axis poles. Likewise, there is no poles over there in the origin. Next part will overtake these two. Okay, and there is no plot over there in the negative side of the imaginary axis. Next plot will overtake this as like this. Okay, so we can say that the path, how many paths are there? So we can say over here, okay, C2, then first C1, C2, C3, C4, C5, C6, C7. Okay, number of counters we will make it increase based on it. Okay, and next the poles at origin. There is a function like here. Now I am going to teach you a problem. That is k divided by s into s plus 2 into s plus 10. I can find out the poles. What are the poles here? Poles is equal s is equal to 0, which means the poles are at origin. Okay, so if the poles are at origin, and what are the other poles here? S is equal to minus 2, S is equal to minus 2, and the poles are on the left half of the S plane. If this axis means the Nuquist quadrant will be like this. Okay, so there is no poles on the there is a poles on the origin. So the Nuquist plot will be overtaken. Okay, so the contours are C1, C2, C3, C4. Okay, so based on this, now we are going to take a problem. So, for we have this is all what all these are we are drawing in the S plane. For what plane we have to map this all with GH plane. So to map that way, what are the thinking we want to know that C1 for mapping C1, what is the frequency ranges from 0 to infinite. Okay. And next, for C2, what is the condition? For C2, in real axis it comes towards infinite. Okay, we can't predict where this counter is going to come in the real axis. That is infinite. So we can say that R is infinite to the limit R e to the power j theta minus j theta. So the value of theta ranges from where? From here to here, right? So I told you here is a 0 degree means here it is what? Minus 90 degree in the anti-clockwise direction. So the theta ranges from theta is equal to minus pi by 2 to plus pi by 2. Okay. And next, under that condition, whatever transfer function will be like k divided by st into 1 plus st into 1 plus st. That the term and 1 plus st can be assumed as what? S into t. Okay, so itself I told you. That is 1 plus st is equal to s into t. We can assume that. Okay. And next, for mapping of the C3. For mapping of the C3 is what? Inverse of C1. If I draw C1 as like this, what I have to do? I have to draw the C3 the same, inverse of that. Okay. So, it will be an inverse operations for C1, C3. Okay. And next is C4. For C4, what is this here? C4 is over here, right? Comparing to the semicircle over here, there is infinite of radius. Here, what is the radius might be? The radius may be 0. This is our assumption. I am asking saying that in the real part, this radius of the semicircle tends to what? 0. Under that limit, it is r into e to the power j theta. Same here. Theta ranges from what? Here, plus infinite pi by 2 to minus pi by 2. Okay, so by applying this condition, we will be going to solve this problem. First, this will be a quotient. Quotient will be like this. Draw the Nuquist plot for the system whose probable loop transfer function is given by, that is g of s, h of s is equal to k divided by s into s plus 2 into s plus 10. Okay, and also determine the range of k. Right now, also determine the range of k for which the system is stable. So, for which the system is stable. So, what does it mean? I have to find the value for k. Okay, so k is going to be under a condition. I have to determine at what value of k the system will be stable. Okay, I have to find the range of k. Certain range of k will be I have to be finding out. After finding out the range of k, I have to tell at what range the system should be stable. Okay, so what is the first step? First step, what you want to do? Determine poles. First step is to determine poles. So when I determine the pole, what are the poles here? S is equal to 0, S is equal to minus 2 and S is equal to minus 10. So by that I can say that S is equal to 0, S is equal to minus 2 and S is equal to minus 10. By that I can say that my Nyquist plot is going to be, that is the poles in the 0. The remaining poles are in the left half of the S frame. So the Nyquist plot is going to be like this. That is by skipping the poles which is at the origin and to the, this is how Nyquist contour will be. Okay, so under the condition we are going to apply. This is the contour C1 and this is C2, this is C3 and this is C4. The range of frequencies from for C1 is omega is equal to 0 to omega equal to infinite, and for here minus infinite to 0. Okay, so we have to map one by one. Okay, so before doing the map, what you have to find out? Now look at the question. How it is? Look at the question. How it is, D of S? K divided by S into S plus 2 into. Should the question be like this, or we have to do something? It should be in the form of 1 plus ST. Okay, first we have to take the constant outside. So it will be, it should be in the form of 1 plus ST. So K divided by S into. So if I take the 2 common outside, it will become 1 plus S by 2. Right? S by 2 means, which means 1 by 2. What is the value for 1 by 2? 0.5. Yes. So first thing. The next step, I should take the value for 10 outside. So if I take the 1 means 1 plus 1 by 10 means it is 1 by 10 is 0.1 into yes. Okay. So the denominator, what are the multiplication? 2 into 10, which means 20. So K divided by 20 into S into 1 plus 0.5 S into 1 plus 0.1 yes. So if I take this as 1 by 20, what is the value for 1 by 20? 0.05 K divided by S into 1 plus 0.5 S into 1 plus 0.1 yes. Now this is our G of S, H of S. First you have to solve this like this. Next what you have to do, you have to replace the S with J omega. Okay. So so the next is step 2, mapping of C1. Now you know what you have to do. Okay. After we achieved the transfer function, we have achieved converted into J omega, and now the transfer function is ready. Next what you have to do, you have to map the contour, that is explained to the GH plane. Okay, first step, that is step 2. This is the step 2, mapping of the C1. Okay, to map C1, the value of omega ranges from where? From 0 to infinite. Next what you have to replace S with J omega. So after replacing S with J omega, what happens? C of J omega, H of J omega will be equal to 0.05 K divided by J omega into 1 plus our quotient. Instead of S, 2 is there, J omega. Okay. Next what you have to do, you have to find the, in this question what you have to find out, you have to find out the ranges of K. After finding the ranges of K, we have to say that at what range the system is stable. Okay, so for next what we are going to do is we have to multiply this. There is 1 into 1 will become 1. Okay, and here 1 into 0.5 J omega is 0.5 J omega. Likewise 1 into 0.1 J omega is 0.1 J omega. If we add both, 0.5 plus 0.1 will become 0.6 J omega. Okay, and here if I multiply these two, 0.5 into 0.1 will become 0.05. Okay, so 0.05 into J will become J square. J square value is minus 1. So we get plus into plus only. The J square is minus 1. So it will become minus 0.05 omega. Omega into omega will become omega square. Okay, and next time what I am going to do is I am going to multiply this J omega towards itself. Okay, if I multiply this, what will become here? J omega plus 0.6 J square omega square minus 0.05 J omega into omega square will become omega cube. Okay, and now J square here. So we can make it mark it as minus 1. So already there is what is here? plus. So plus into minus will become here minus 0.6 omega square. Okay. In this remaining terms, what I am going to do, I will take the j omega common again. So if I take a plus j omega common, what will remain here? 1. The j, can you get my point? See, in this point I am solving as it is. That is, there is a 0.6 over here. Here the j square is here. J square is what? Minus 1. So I can say that it is minus 0.6 omega square. In the first term and the third term, what I am going to do? I am taking the j omega common. So if I take a j omega common from the first term, what will remain there? 1. And in the third term, what will remain there? Minus 0.05 j common, omega common, the omega square will remain. Okay, so to find out the phase crossover frequency, okay, to find out the crossing, where now we know omega that is from 0 to infinite, it is going to be a contour, but where it is going to cross, that we want to find out, right? To find out that, what I am going to do, you have to imaginary part equating to 0. Equate the imaginary part to 0. What is the imaginary part here? The second term, that is omega into 1 minus 0.05 omega square. This term is imaginary. I am equating it to 0. So this term, if omega comes here, it will also become 0. So the remaining is 1 minus 0.05 omega square, that is equal to 0. So if I bring this 1 over right hand side, it will become minus 1. So if I cancel this both minus, it will be like 0.05 omega square is equal to 1. If I take square root of it, that is omega is equal to 1 by 0.05. If I take the square root of it, the answer will be like 4.472 radian per second. Okay. So next to what, this is the phase crossover frequency. Now we found out. So next to what we have to do, we have to substitute this omega in the real part. What is the real part here? Minus 0.6 omega square. So the real part, that is equal to, real part is entire this everything. Okay. 0.05. I use the k here. Okay. 0.05 k divided by 0.6 into 0.05 k divided by minus 0.6. Okay, that is into omega square. Omega value we just find out now. 4.472 into 4.472. If we multiply this both and if we divide this, we will be getting what? The value for in the real axis. Okay, that is minus 0.00179 k. That is the crossing point. Okay, so now listen, given the transfer function. From the transfer function, what type of transfer function it is? What is the type number there? S to the power there it is 1. So type number is 1. What is the order number there? Order means we have to multiply. 3. So order is 3. Okay. So the polar flow starts from where to where? Polar flow it always starts from 0 to infinite. Okay. After saying that, the crossing frequency is where? Minus, just now we found out the crossing frequency is minus 0.00417. So from 0. Okay, where it is going to cross? This is the minus with the multiplied with the k. We don't know the value for k now right now. So just it is going to be anyhow it is in the negative real axis. Okay. So mark somewhere here. So where the first C1 is going to be? C1 is going to be like this. Clear? Next what we have to do? We have to map the C2. Okay. So for mapping C2, what is the theta ranges from? Minus pi by 2 to pi by 2. Next what you have to know, you have to know the formula, that is r tends to infinite limit r e to the power minus j theta. We know the ranges of theta and what is the assumption we are going to place here? 1 plus st will be replaced with the term s into t. Okay, so if I do that, g of s h of s will become what? What is the quotient will be? 0.05 k divided by s into, let it be s into. 1 plus st can be replaced by s into t. That t is what? 0.5. So it is 0.05 into s. Now you get my point. The next 1 plus st. What is s t over there? 0.1. So it is 0.1 into s. Okay. So now, this s. 0.1 into s. And now what is that? Just multiply this. That is in the numerator there is 0.05 k. The denominator what it is 5 into 0.05 into 0.1 it will become 0.05 and s into s will become s cube. So if I cancel those constants, what will remain? K by s cube. Okay. So the value of s, what it is the condition? That is r tends to infinite limit r e to the power j minus theta. Okay. One more thing you have to remember that is j minus theta. That is n number of n minus m. Okay, into what? J e to the power minus j theta into n minus m. Here what is the n? The number of poles is 3. And what is m here? 0. There is no 0 here. So it will become 3. Okay, 3 minus 0 it will become 3. Okay, so how will be the form will be then when theta equal to pi by 2, g of s will be r tends to infinite. So it will become 1 by 0. Then it will 1 by infinite it will become 0. So itself I told you. It is 0 into e to the power minus j 3. Who is 3? N minus m. Number of poles minus number of zeros is 3 over here. Theta is pi by 2 minus j 3 pi by 2. Clear how to find this? And next is when theta is equal to minus pi by 2. This minus into minus will become plus. That's it. This remaining thing will say. So the ranges of the degree ranges from changes from where to where now? 3 times the pi by 2 means 3 times the 90 degree. 3 times the 90 degree means minus 270 degree to plus 270 degree. Okay. So this is the S in S plane. This is the C2. We are going to map this to the GH plane. How it will be? 3 times the 90 degree. Okay. So first from where to where? Minus 270 degree to plus 270 degree. Okay. So 1, 2, 3 cycles. Okay. This is the mapping for C2. Have you get my point? How to map this? And next mapping of C3. Mapping of C3 is what? Inverse of C1. C1 is 0 to infinite means C3 is minus infinite to 0. So the mirror image of the C1. Okay, with respect to the real axis, the mirror image of the C1 is the C3. Just I have drawn as in inverted at the same point of here is what? Minus 0.0. What is the point here? Minus 0.00417 K as the same crossing point but in the inverted form. Okay. So the last is mapping of C4. Right up to this. So the last is mapping of C4. The C4, what is the condition? We know that is we are ranging from minus 90 degree to 90 degree. Same over here. But the range of R is 0. R tends to 0. R e to the power minus j theta. Here, when j theta is to the range y, that is n number of volts. That it will be what? N minus m. Here we don't need to multiply that. That is y. Let it be any constant. Let us assume that it will be any constant. So that is multiplied with y. We don't need to solve that particular what is that y. You don't need to find it. Okay. Next, what you have to do? You have to assumption that it is 1 plus st is equal to st. Here it is what? 1 plus st is equal to 1. So if I substitute that 1 plus st is 1 means what will happen in the denominator? Wherever there is 1 plus st form, it will become 1. So the g of such will become 0.05 k divided by s. So next condition, what I know for the value of s is equal to r tends to 0 e to the power minus j theta y. So if I substitute 0 over for s, then it is what? If I substitute 0, it will become 1 by 0. 1 by 0 is what? Infinite. So when theta is pi by 2, what is the g of such will be? Infinite e to the power minus j pi by 2y. When theta is minus pi by 2, what is the g of such will be? Infinite e to the power plus j pi by 2 into y. Okay. So under that condition, how will be our C4? C4 will be infinite, right? With an infinite radius, it will be in the circular arc as an real axis. In the real axis. Okay. The real axis, what it is? Infinite. Plus infinite. So what it is here? Plus infinite, plus infinite. We don't know. Real axis, positive side where it goes to come. Now what is the radius for C4? Infinite. Okay. The circular arc with infinite radius. That is the count of C4 for GH map. After that, what you have to find out? Stability analysis. That is the value of K you have to find out. What do you know from the initially? Yesterday I have discussed that for GFS of is equal to what it is. When I equate the denominator to 0, what will become? Unity feedback system, H of s will become 1. So 1 plus G of s is equal to 0. So G of s is equal to minus 1. For Nyquist plot, what is the condition for the stability? Minus 1 plus, there is no imaginary part, minus 1 plus 0 plus J0. Okay. So if I equate the G of s, H of s, we know that it is minus 1 plus J0 is the standard form for stability. What is the stability? We have found here the crossing point, that is minus 0.00417 K. If I equate to the stability condition minus 1, what will the value for K again here? That is K is equal to 240. Okay. After that, overall like this what you have to draw. Okay. So listen carefully. First, what is the plot we have marked? C1. From 0 here started, right? Just to move away from the 0. It won't be 0, right? So from here to this is the first, that is C1. Okay. After that, what do we have marked? Minus 270 degree to plus 270 degree C2 mapping. That is here. Over this. Okay, this like. This is what? C2. Okay. In the direction or other direction arrow. Okay. And now C3 is what? Inverse of C1. So inverse of mudiyudu adhe edathula. In the crossing. This is the K value. Okay. This is the value. This is double line. Again, double line for your reference. Double line. Okay, again, C3. Okay, next C4 is what? Infinite circular arc. From over here to here. This is what? C4. This Nyquist entire plot you have to draw with respect to variable. This in standard G plane is said to be what? U plus JV form. So the real axis is taken as U and the imaginary is taken as JV. Or they explain it as sigma and here it is J omega. Okay, so you have to write here. Here the omega ranges from 0. Here the omega ranges from plus infinite. In downwards here omega ranges to minus infinite. And what is the real part over here? Real part is 0. Here what is the real part? Here it is infinite. Okay, and we found what K is the value for 240. Now the K value is known. Okay, now fix 2 points. Okay, so one point is over here and the other point is over here. Okay, so if I take in this condition, that is K is less than 240. K value is determined. Under what time it should be stable. So I am taking this condition as less than 240 since it lies between the encirclement. Okay, it comes under the contour, Nyquist contour. So under this condition, our Nyquist plot will be stable. You have to give the condition. If I consider this point, this point will be how? Greater than 240 since it is away from the Nyquist contour. Okay, so under this condition, we can say that it will be unstable. Okay, 2 point we have to say that. That is the point which lies in the where? Nyquist contour. Okay, next what we have to say that? That is comes under the encirclement. Okay, encirclement of the GH plane. Okay, so the system is stable. If K value is above 240, the system may become unstable. Okay, that is the entire Nyquist plot. Is that easy for you?